So after checking out an example of asynchronous JavaScript, let's now dive in a bit deeper and learn everything you need to know about synchronous and asynchronous JavaScript code, as well as the event loop. So all the code we've been writing in this course up until this point has always been synchronous code, which simply means that one statement is processed after the other, line by line, in a single thread in the JavaScript engine. So something like this is an example of synchronous JavaScript, where the first function is executed, logs "hey there" to the console, calls the second function, which then prints "how are you doing" to the console, and then finally the end is logged to the console. So one instruction after the other in a synchronous way. Now this here is an example from our previous lecture, and as we learned, this one involves some asynchronous JavaScript. So again, the first function gets called, logs "hey there" to the console, and then calls the second function. Now this function calls the setTimeout function, which is basically like a timer that will execute the callback function that we passed into it after 2000 milliseconds. However, this will not make the code stop for 2 seconds, but instead the function returns, goes back to the first function, and logs the end. Then, after the 2 seconds actually have passed, async "hey there" is logged to the console. Now, why does the code move on instead of waiting for the timer to finish? Well, before I show you how and why this actually works behind the scenes, let me quickly show you another example. So, suppose we select an image from our DOM and pass it into a processLargeImage function that we created. Now, we know that this function is going to take some time to process the image. And so, just like before, we don't want the code to have to wait. So we don't want it to stop while the image is processing, because that would be terrible in some situations. So what we do here is to also pass in a callback function that we want to be called as soon as the function is done processing. And just like that, we have created asynchronous code. So that is the whole philosophy behind asynchronous JavaScript. We do not wait for a function to finish its work and then do something with the result. Instead, we let that function do its job in the background so that we can move on with the code execution. We then also pass in a callback function that will be called as soon as the main function has done whatever it had to do. We then move on immediately so that the code is never blocked, which means that it can keep processing the code in a synchronous way line by line. Because if the code is actually blocked, then nothing really works on the page during that time. Like for example, you can't click any buttons or anything like that. So in summary, we can use callback functions to defer actions into the future in order to make our code non-blocking. But how does that actually work behind the scenes of JavaScript? Well, that's where the event loop comes in. So the event loop is part of the bigger picture of what happens behind the scenes of JavaScript when we call functions and handle events like DOM events. So we already talked about the execution stack and also about the message queue when we first talked about events, and so this should be nothing new to you at this point. Now, what is new here is the event loop as well as the web APIs, which together with the execution stack and the message queue make up our JavaScript runtime. So this runtime is responsible for how JavaScript works behind the scenes as it executes our code. And it's extremely important to understand how all these pieces fit together in order to execute asynchronous JavaScript. So let's now take a look at how the code from the last lecture is executed inside our JavaScript engine line by line. So it starts by calling the first function, and so as we already know, an execution context for that function is put on top of the execution stack, which can also be called the call stack. In the next line of code, the console.log function is called, and so a new execution context is created and the text is logged to the console. Then the function returns and the execution context pops off the stack. Moving on to the second function, a new execution context is created, and in the next line, the setTimeout function is called, which causes yet another execution context to be created. Now, before we move on, where does this setTimeout function actually come from? Well, it's part of something called the web APIs, which actually live outside the JavaScript engine itself. So stuff like DOM manipulation methods, setTimeout, HTTP requests for AJAX, geolocation, local storage, and tons of other things actually live outside of the JavaScript engine. We just have access to them because they are also in the JavaScript runtime. And so this is exactly where the timer will keep running for 2 seconds, asynchronously of course, so that our code can keep running without being blocked. So when we call the setTimeout function, the timer is created together of course with our callback function, right inside the web API's environment. And there it keeps sitting until it finishes its work, all in an asynchronous way. So again, the callback function is not called right now, but instead it stays attached to the timer until it finishes, okay? And so since the timer keeps working, basically in the background, we don't have to wait and can keep executing our code. So let's do that. So next up, the setTimeout function returns, pops off the stack, and so does the execution context of the second function, which now returns as well, and so we're back to the initial first function. Now we just log the end to the console, and so we give ourselves a new execution context, print the text to the console, and pop the context off again. Next, the function returns, and so we're back to our original state. So right now we have executed all our code in a synchronous way and have the timer running asynchronously in the background. Now let's suppose that our 2 seconds have passed and so the timer disappears. But what happens to our callback function now? Well, it simply moves to the message queue where it waits to be executed as soon as the execution stack is empty. And this is exactly what happens with DOM events as well. Remember that? And that's because it actually works the exact same way. So in the case of DOM events, our event listeners sit in the web API's environment waiting for a certain event to happen. And as soon as that event then happens, then the callback function is placed on a message queue ready to be executed. Alright, so how are these callback functions in the message queue executed? And that's where finally the event loop comes in. So the job of the event loop is to constantly monitor the message queue and the execution stack and to push the first callback function in line onto the execution stack as soon as the stack is empty. Okay, so in our example here right now, the stack is empty, right? And so we have one callback waiting to be executed, and so the event loop takes that callback and pushes it onto the stack, where a new execution context is created for that function. And that's it. That's what the event loop does. So inside that callback function now, we simply run the log function, which logs async hey there to the console. Then the context pops off the stack and we're done. Now, if there were some more callbacks waiting right now, like data coming back from an AJAX request or the handler of a DOM event, then the event loop would continue pushing them onto the stack until all of them were processed. And that's how the event loop works. It's actually quite straightforward, right? But still, if you ask 95% of the JavaScript developers out there, they will not really be able to explain you this stuff. And so you just gained a huge competitive advantage over them. Now, please just note that the setTimeout function that we used here as an example is really more to simulate a more real-world asynchronous function, like doing an AJAX request to fetch some data from an external API, just like we're going to do in one of the next lectures. Okay? So I hope this made sense to you so that you're now ready to move on in order to use this stuff in practice.